On this quiz, you have to turn it in, make sure it's turned in up there. How do I solve the first one? Cross multiply. What do I get when I cross multiply that way? How about that way? Make sure you got your calculators out helping me. Then what? So what's x equal? That's a pretty easy one. The other's not quite as easy. Got to be able to do these though. That's something that you should have been able to do from 5th grade, 6th grade, somewhere, wherever you learned proportions at the first time. Second one, what do I get when I cross multiply this one? That way?
286.
Where most of you are having trouble is, you probably had some teacher, and I don't know who it was, I probably shouldn't say anything bad about any other teachers, but they probably told you, you multiply these two, just take your calculator, you multiply these two, then you divide by the other number. Does that help you when you get to the harder stuff? No, it helped with that easy stuff that you did back in 5th grade or 6th grade, whenever it was. And I got a son that's in 6th grade, and I know that that's the way his teacher teaches him, whatever is the easiest for that certain moment. And that's not what you need to know. You need to know how to do problems, all of them, not just the easy ones. All right? Here, what do we do next? Divide by 9. What's that give us?
31.7.
Now, I'm going to tell some of you this. Actually comes out like 31.8. I would accept that answer for right now, but no, some of you at some point, everybody, every junior has to take the ACT because they're going to make you through the school from this year on, right? So you have to take the ACT, and I'll almost bet that that answer will be the wrong answer on the ACT test. I'm not sure. I'm sure she's told me, but I don't remember. Because a lot of times on the ACT, they want the exact answer. Now, I heard somebody say this, 31.7. It actually rounded to 31.8 because it was like 7.7, right? Both those answers are going to be wrong on the ACT because they're going to ask you for the most precise answer. And you've got to be able to pick out the most precise answer. And somebody else might say, well then, maybe you go out a couple spaces farther. That's going to be wrong also. Then they'll say, well, maybe they wanted it rounded off to the nearest whole number. That's even less precise than all the others. All right? To get the most precise answer, and you could use your calculators to do this, when they're saying the most precise answer, you've got to know what that calculator is telling you when it's telling you that decimal. Some things you ought to know just automatically. If you see this on your calculator, you should know that that's what is a fraction. Say it? A third. You should know that by now. So if you see that, don't write down 0.3 repeating or any of that other stuff. Write down 1/3. When you see this, be careful on this one. A lot of people mess up on this one. What's that as a fraction? Because everybody wants to look at this and say, oh, that's 1/3, so that's got to be 1/6, and that's not what it is. What is it, Evan? 2/3. So those two you got to know. You see that on your calculator when you divide something, know that that means that's 1/3 and that's 2/3. Some other ones that you should know that's related to this one. When you divided this out on your calculator, you got something that looked like this, 31.77777. I don't know how far the calculator goes out, but then the last number was 8 because the calculator rounded it up. All right? You start looking at this, grab your calculators, everybody. Even my friend Lexi here, who's going through her binder right now, is going to grab her calculator and do what I'm telling her to do. Figure this out. 1 divided by 9. Punch that into your calculator. What's it say? 0.1 repeating. Punch this into your calculator. 2 divided by 9.
What, you use the minor again?
0.2 repeating. Punch this in, 4 divided by 9. 0.4 repeating. Let's look back at what you got on your calculator here. What'd you get? 7 repeating. Using that pattern, what do you think it is? 7/9. So what do you think the correct answer is going to be on the ACT test? 31 and 7/9. That's going to be the one they want. They want that exact answer, not the rounded off answer. Now, if I did this on my calculator, and I know they want an exact answer, and I did 286 divided by 9, I don't want to do divided by, I shouldn't have done that, so let's clear that. 286, what button should I hit? Instead of divided by, if I hit the ABC button, 9, then hit enter, and what's it tell me? 31 and 7/9. Alright, so sometimes when you want that exact answer, you gotta be able to pick it out or know how to get to it. Just like when we were doing the radicals last class, when you have something like 3 radical 2, that's the exact answer. Sometimes they don't want the rounded off answer, they don't want the calculator answer. And you gotta know that, hey, this says the exact same thing, I think, as that. Those two are the exact answer. Somebody help me out, what's the square root of 18 on your calculator?
4.224.
That's a rounded off answer. That's an exact answer. That's an exact answer that's not simplified. So all 3 of those are the same answer, but sometimes they want one, sometimes they want the other. Depends on the problem. Next one, what's the first thing? Some of you have trouble with this one? So make sure you're watching now, because these are the 5th grade ones up here where you just cross multiply and solve. You gotta be able to do these extra ones. What's the first thing I told you to do on one like number 3? What do you do right here? Put parentheses on that. You gotta put parentheses around that. If it's got more than one term in it, if it's a binomial, you have to put parentheses around it. Now when I cross multiply, what do I write down? This is where a lot of you are having trouble, and where you're going to have trouble on the test next week, because I'm not going to give you a whole bunch of just little simple ones like this. All right? We're not that young anymore. We got to be able to do the harder ones. Equals, what do I write down on the other side? 10x. How do I start to solve that?
3x.
Distribute. Evan says it gives us 3x plus 9 equals 10x still. Now what? Minus 3x on both sides. What's that leave you with on the left-hand side? On the right-hand side? Just 7? Now what do you do? Divide by 7. Grab your calculator. Is 7 going to go into 9 evenly?
No.
What if they want an exact answer? Do you want to grab your calculator?
Yeah. No.
You could use the ABC button and it'd tell you, but how many 7s are there in 9? 1. How many left over?
2.
2 over what? 7. That's the exact answer. You grab your calculator, you get like 1.24 or something.
You have the test.
228. Huh?
You have the test.
I would rather, this is a better answer than that rounded off answer. And again, if I put a multiple choice question on the test, and I put this answer on there, and not the decimal answer, are you going to be able to look and figure out which one it is? I hope so. And I hope you don't have to take the time, you know, if I put, let's say, for this problem, I put 1 and 2/7 as one of the answers, then the next one's 1 and 2/9, and the next answer is 1 and 3/8, and the next answer is 1 and 4/5. I hope you don't have to punch the original one in the calculator and get 1.28, and then go back and divide each one of those to see which one comes out to 1.28. That takes too long. Questions on the 2 worksheets? Make sure your names are on both worksheets. You're gonna hand them both in here in just a couple minutes. Questions, problems you wanna see worked off of them.
Number 8.
You'll have to tell me a page number 2.
300.
3 what?
309.
309. So make sure your name's on both of them. Page 309, number 8. Number 8, they gave you the wrong thing on this. So let's change it real quick. Instead of finding UT and RT, we want to find VT and ST. So we want to find those two segments instead of the two that they gave us. That might be beneficial there. What's these arrows tell us about these two segments?
Arrow.
They're parallel to each other. Big deal with what we're going to do today, so make sure you know that. 15, 6, I got all that. How many triangles in this picture?
33.
Identify. Identify the similar triangles, find X and find it. So there's a bunch of answers we got to do on this, right? First thing I'm going to do, you see two triangles here. What should you do to them?
Put 'em on.
Separate them. So I'm going to separate the small one. I forgot my letters. I forgot something. It's S. That's R. That's U. T. B. Name this small triangle for me. What's this? U. This one. Big triangle. That's horrible. Close enough, right? Big triangle. Now, first thing they wanted you to do is match up the two triangles. If these two are parallel, what can you tell me about this angle and this angle? They're congruent, right? The angles are congruent, sides are proportional. So those two are similar. Anybody remember what those angles are called when you're dealing with the parallel lines? It's the ones where you smash the lines together. They're corresponding angles, right? And we know that corresponding angles are congruent. What do you know about these two angles? They're congruent. Is that enough to say that the big triangle and the small triangle are similar to each other? Yeah, by what? Angle. Remember the three things that we covered last time? One of them was angle. What was the other two? Side similarity and side angle side similarity. So we know the two triangles are similar. Name the small triangle for me. UVT. Does it really matter how you name the first one?
No.
No. What's U match up to
R.
in the big triangle? R, good. What's V match up to? That's part of our answer right there. That's one of the things they wanted. Then they wanted us to find X. To find X, we got to set up a proportion. This is one of the things that you guys said you were having trouble with. Let's go back to these two triangles before I do this. How long is this side in the small triangle?
No.
Small triangle. 6. How long? How about this side? Do we know it?
No.
This side?
No. X
In the small triangle, it's X minus 6, right? Big triangle, how long is this side?
14.
Here's where you got to be careful. How long is segment ST in the big triangle? We got to add both these expressions together, right? What's X plus X give us?
2X.
It's 2X. What's minus 4 and minus 6 give us? Minus 10. So now how long is segment ST? 2X minus 10. All right? Now when we go to set up our proportion, first one you want to match up to get your scale factor. You want to match up two that you know numbers for. Give me two sides that we know numbers for.
6 and 14.
6 and 14. Now if we wanted, could we reduce that down
Yeah.
and make it easier to do the cross multiplying and stuff? Yeah. So we matched up 6 to 14. We matched up that to that. What's going to come first on the other one?
X minus 6.
X minus 6, good.
2x minus 10.
2x minus 10. And what did we just say on problem number 3 there? Put parentheses around that. Put it around both of them. Anything that has two terms in it. See how it's got a minus sign or a plus sign or whatever? Anything that's got two terms, put parentheses around it, it's gonna make it easier on you. Now we cross multiply. What do I write down?
6 parentheses 0 equals
Multiplying the other way.
14 parentheses x
What's the next step we're gonna do? Distribute for all of it. Somebody tell me what's this first one when you distribute?
12x minus 60.
12x minus 60. What's the second one?
14x minus 84.
Everybody agree with that? Now what? We got x's on both sides, right? So what do you gotta do?
Minus.
Get them all together. Which one are we gonna move? The 12 or the? So subtract 12x on both sides. Over here, what's that leave you? Be careful. Negative 60, good. On the other side, what's it leave you with? 2x minus 84. Now what?
Plus 84.
Add 84 to both sides. On the left, what's that leave you with? 24, you're right. 24 equals, how about on the right? 2x, what's the last step? Divide by 2, what's x equal? So that's part of our answer, that x equals 12 is part of our answer. What's the other thing they ask us to find? They actually ask us to find the others. These two links, right? How do I find VT? How am I going to find the segment VT? Yeah, I know, that's, we changed it. Plug in. Where do I plug it in at? Right here, x minus 6, in place of x, what do I stick in there? Let's just put 12 right there. What is 12 minus 6? 6. So that's segment VT. That's another one of our answers. How am I going to find ST? It's probably going to be easier to go over here to where we split it off, right? What do I plug in there? 12. So 2 times 12 minus 10. What's 2 times 12? 24 minus 10. Again, make sure your answers make sense. Does it make sense for ST, this whole length right here to be 14, and this length right here to be 6? Yeah. Could we plug in here, and what's 12 minus 4?
Negative 2.
12
No.
minus 4.
8.
8. So that part's 8. This part was 6. What's 8 plus 6?
14.
Is that the whole thing? Is that how long we said it was? Yeah, so you could go back through and check your answer and make sure everything's working out the way it should. Make sure you got X right. Problem like this on the test next week. 1 point for naming the two triangles in the correct orders. 1 point for setting up the proportion right here. 1 point for finding X. 1 point for finding VT, 1 point for finding ST. How many points would this problem be worth then? 5 points. Alright, so for those people who just look at it and go, oh man, those are the ones I don't understand, and just leave it blank, is that worth missing 5 points for? No. Could you at least try to match up the two triangles? Yeah, write down something. Triangle something's congruent triangle or similar to triangle something. Could you at least draw a proportion and try? Match them up somehow. Even if you can't solve this, even though you should be able to. Other questions? 7 on 309. 308. Number 7 on 308. We're going to do these problems, a lot of these problems next class. The heights of two vertical posts are 2 meters and 0.45 meters. When the shorter post casts a shadow of 0.85 meters, what is the length of the longer post shadow to the nearest hundredth? What's the first thing I should probably do on a problem like this one? Draw it. So we got a post here. That's our first post. Do we know anything about that first post? What they tell us about it? It's 2 meters. And apparently it's got a shadow, right? So I draw the shadow. Do we know the length of its shadow? Yes, no, maybe? We don't know it, do we? So what do we let it be? That's going to be our X. We got another post. Do we know anything about that post? What is it? The post itself. Is it 0.45? Oh, you're right. My fault. Not thinking. And it's got a shadow. We know anything about its shadow? 0.85. Before I go much farther, certain time of the day, you have a shadow that's like this setup. What should be true about X right here? Looking at the way this other shadow for this other post is, before we go any farther.
It should be bigger than the size of the back of the post.
Should be bigger than 2 right here, right? If this shadow is longer than this post, then this shadow should be longer than this post. So when we get our answer, we know it should be more than 2. And when I'm saying, make sure your answer makes sense, that's what I want to see. That you know, hey, we got to make sure that this answer makes sense for this problem. Now, once you have this, all you're going to do is set up a proportion. Notice you got 2 triangles here. And those 2 triangles are similar to each other. What's my first ratio going to be?
2.45.
Now, are there many ways that you could set it up? Yeah. I might suggest, just because, and with this one it doesn't really matter because you have the decimals in there and you're probably going to use your calculator anyway, but I might suggest that you try to, when you're setting it up, and I probably shouldn't even say this, but try to put the smaller numbers on top. Because if you put the smaller numbers on top, then your calculator will reduce it as a fraction and keep it as a fraction instead of a mixed number. Because if the bigger number's on top and you try to reduce it, your calculator is going to tell you a mixed number, and that just seems to confuse some people. All right, so if you put the smaller numbers on top, that might make it easier. So maybe this time instead of 2 over 0.45, we might have went what? 4.5 or 0.45 over 2. Now it doesn't matter. Let's go back to this one. I'm probably going to confuse the heck out of all of you because I'm going to do 2 of them at a time. If we went 2 matches up to 4.5, what's our other ratio going to be? To what? 0.85. X matches up to that. Yep.
Could you set it up where like could be 2?
Let me do this real quick and then I'll do it. If we did 0.45 matches up to 2, what's this ratio going to be? 0.85 over X. All right? Now, is that the only 2 ways to set these up? No. Lexi's getting ready to ask me a question, and she's probably going to say this. Is it all right to set it up that way?
No.
Yeah, it's fine.
Yeah, that's fine.
Yeah.
Because all she did was she matched this over this, this over this. Watch what happens when you cross multiply here. What 2 things am I multiplying there? 2 and 0.85, right? What 2 things am I multiplying there? 2 and 0.85. What 2 things am I multiplying here? 2 and 0.85. What 2 things am I multiplying here? Is it the same for any of those 3 setups? Yeah. So there's several different ways you could do it. Now the bad thing with telling you several different ways, I try to keep it to one way, so that way you don't mess it up at some point. Because are there wrong ways to set it up also? Yeah. No matter which of these 3 ways you set that up though, it's going to come out the same. So when we cross multiply here, let's just do this one because I got more space here. What's 0.45 times X?
Wait, for X.
On the other side, what's 2 times 0.85?
1.7.
Now what do we do?
Divide by point.
Grab your calculator. These are decimals, so do we really care if we get a decimal answer? No, it's probably what we wanted in since we started with decimals. What's x equal? Three point what?
7.8.
7.8. And that's meters. It said round to what?
Meters, hundreds.
So did I go out enough places? Yeah, that's the hundredths place, right? So 3.78, let's go back to what we said originally. Does it make sense for the shadow of that post to be 3.78 meters? What do we say should be true about it? Should be bigger than the length of the pole for this problem. Is your shadow always bigger than you? No. When is your shadow bigger than you? What times of day? Give me a time of day when your shadow would be bigger. Early in the morning, maybe? Once the sun's out, when else? Late in the evening. How come? How come your shadow's bigger early in the morning, late in the evening? If I'm standing here, the sun's got what towards you? More of an angle, right? Early in the morning, sun's over here. Late in the evening, sun might be over here. You're going to cast a longer shadow. When's your shadow going to be the smallest? Probably noon, 1 o'clock, since we have a time change in this area. It's not always just noon because the sun's not always in the sky the same spot, but whenever the sun is right above you, right? Then your shadow is going to be smaller. If we went outside right now and it wasn't raining or whatever it's doing out there, the sun was shining, would I have much of a shadow right now? Probably not. It'd probably be real small. Other questions? Say it again. 4 on 310. 4 on 310. How many triangles in this picture? 2. You got the small one. Huh? You got the small one and the big one, right? Now on number, yeah, they want us to name the similar triangles too. Let's go N, J, gotta put this down here, K, M, L. Let's just name this real quick. Name me the small triangle. KML. And it's similar to, remember, if these two are parallel, what do you know about these two angles? They're corresponding angles, so they have to be congruent. What do you know about these two angles? They're congruent. So when we match them up, we want to make sure we match them up that way. So K matches up to what? J. M matches up to N. And L matches up to L. Now I wanted to do that way because I want to show you something, because this is part of what we're going to learn today. So this will probably be the last problem so that we can move on. We'll see. Maybe Evan, just for you, maybe I'll do one more. 6x plus 2 is that. This is x plus 5. Is that right?
Yes.
My picture looks pretty ugly because I messed up a couple of times, but what we're going to cover today says instead of splitting these two triangles off and drawing the small triangle and the big triangle and doing all that stuff like we did on the last one, if we know that these two are parallel, we're going to have a theorem that says this part has to match up to this part the same as this part matches up to that part. So instead of have to split them up and add these two together to get L in, the whole thing there, and do all that, we don't have to do that. So watch closely, because some of them this will make it easier. Now, is this going to work for every problem? No. First thing you got to do is, we don't know this part. Can we find it though? KL right here. Can we find that length? How? 24 minus 8, what's that give you? 16. Now, let's set up our ratios over here. Give me one ratio we can set up. 8 to 16. Now this goes right back, that's not the way I told you to set it up. I said to go this part and this part. Oh yeah, no, I did say that, didn't I? This part and this part. Could we have went across ways this way? That's the way I thought I told you to do it. And that goes back to what Lexi was saying. Is there different ways that these could be set up? Now with that 8 and 16, because I don't know my 16 multiplication facts, I know Brianna probably does. She knows 16 times 4 and 16 times 8 and all that stuff, but I don't know it. What could you do to 8 over 16? Reduce it. What's it reduced to? 1/2. Is that going to make our multiplying a little easier? Oh yeah, a whole lot easier. All right? What's going to go on top of this one? If we went 8 to 16,
X plus 5.
x plus 5 and x plus 2. What do we put around each one of those? Put the parentheses around each one. Now what? Cross multiply. What's that give us when we cross multiply that way? Let's just go ahead and do the distributing while we're doing this because it's pretty easy. 1x plus 2. So x plus 2. How about the other way? 2x plus 10. Now what? Minus x on both sides. End up with 2 equals what?
1x plus 10.
X plus 10. Now what?
Minus 10.
Minus 10 on both sides. Come on. -8 equals x. Now that confuses a lot of people sometimes. Is it alright for x to be -8? Yeah. I don't know. We need to go back and look at it and see. If I plug in -8 right here, is that going to work? What's -8 plus 5? -3. Can the segment NM be -3?
Yeah.
So did I do something wrong? 24, that's 16 down there, that looks right. 6x plus 2, x plus 5. Keep looking at your paper there. Let's see if we do it out, splitting off the triangles if it works. So we came up with x equals -8, right? Let's do this. We got, for the small triangle, we got 16. For the big triangle, we got 24. That's the whole length. For the small triangle, we got 6x plus 2. For the big triangle, if we add those two together on that top side, what do you come up with? Those two expressions, you add them together on that top side, what do you come up with? What's 6x and x give you? 7x plus 7. Everybody agree with that? Put parentheses around this. See if we did something wrong here. Could we reduce this to make it easier? Anything, what will go into both 16 and 24? Anything bigger? 8 will. 8 will go into 16 how many times? 8 will go into 24. Cross multiply. Do the cross multiplying for me and do the distributing so we don't have to waste so much time on this.
18x plus 6
Equals
14x plus 14.
subtract 14x on both sides. What's 18x minus 14x? Move the 14 over the 4x. Let's go ahead and move the 6 over. You move the 6 over, what do you come up with? 8. Divide by 4. x equals 2, so I must have did something wrong in my math on the other one. Because now we got x is 2, and that sounds more feasible. If x is 2, how long is segment L, or NL? Segment NL, look at your paper, how long is it? 14? ML is 14, right? Segment ML is 14. How long is segment NL? You got 14 plus, what's 2 plus 5? 7, so that part's 7. What's 7 plus 14? 21. So 14 is one of them, 21's the other. I don't know what I did wrong, I shouldn't have erased it, don't bother me. Hurry, Evan, which one?
7.
8, 310. 310. 310, number 7. Another shadow problem. So let's see, it's got a lighthouse. That's my lighthouse right there. Do we know the height of the lighthouse?
No.
No. So it's going to be X. Do we know the shadow? 128 feet. And what else do we have?
The height of the other one was 5 and 3 inches, like 5.
So 5 foot 3 inches. How long? 8 feet.
When you do the highlight, could you put 5.3?
Now, can you just put 5.3? That's a good question. Is that going to work? Inches don't work that way, do they? Metric system would. Centimeters and meters and all that stuff, but not with inches. So how do I change that? Several different ways you could do this.
3/12.
You could put 3 over 12, so you get 5 and 3 over 12. What's that reduced to? 5 and 1 over 4. Now, if you wanted to not use the fraction, do you know what 1 over 4 is as a decimal? 0.25. So how long is this side right here? 5.25. And we could use that. Could you also change this whole thing into inches? Yeah, you could change it into inches. Could change all that into inches. Now, when you're changing it all into inches, the only bad thing is when you get your X answer over here, it's going to give it to you in inches. You don't have to change everything into inches, just the things that match up. All right? Not everything. But if we do it that way, leave everything in feet. And know that it's 3 out of 12. What if it said 4? 5 feet 4 inches. Instead of 3 over 12, we put what? 4 over 12. What if it said 6 inches? 5 foot 6 inches. 6 over 12, and you reduce that down. What matches up here? 128 over 8. What else? Be careful. What goes on top? X over 5.25. Solve that for me real quick. If it confuses you doing it this way, then sometimes what I teach is if you got this picture right here and it's got that in there, change that into inches. How do you change 5 feet 3 inches into all inches? Not divide. Times the feet by 12. What's 5 times 12? 60. 60 plus 3. So that right there would be 63 inches. How would we change this one into inches? 8 times 12, which is like 96 inches. Change those two. Could we set up a different proportion then? Yeah, we'd set up. How do you what?
That's like a good way to remember how to set up the proportions, because I always get them mixed up.
What I do on especially these shadow problems is I just do it this way. Height compared to height. So the height here compared to the height over here, and then shadow compared to shadow. For those kind of problems. For the triangles, no real easy way to. What anybody come up with for X here?
84.
84, and what's our units? Feet. Does it make sense for that lighthouse to be 84 feet tall? Yeah, lighthouses are pretty tall. How tall is a normal house? I asked a question this yesterday, and
36 feet.
I got answers like that right there. 603, and I got really answers like that. Maybe 25 if it's a two-story. That's a pretty tall house in this area. What's a normal one-story house about how tall?
15.
Maybe 12 feet, 12, 15 feet. And that's if you're going to the very, very peak of it. All right? All three-story. Now, even with Evan says he's got a 3-story house, is it going to be 50 feet tall?
That's from
No, it'll probably be about 28, 27, somewhere around there. Make sure your names are on those. You're going to pass them forward, then pass them all over till Lexi has them.
Yeah, we haven't seen it either.
Quickly, write this down because we got to move along.
Where's it going?
No, don't staple. Just make sure your names are on both of them. Start copying this down. Proportionality theorem. Write quickly because you got about 10 seconds and I'm changing the slide. 9, 8, 7, 6, 5, 4, 3. Before I get to 0 here. Finders due next time. One set of notes. There's like 13 sets of notes, I think. Somebody grab their calculator real quick and divide 1 divided by 13.
1.3.
0.07.
0.07?
Yeah.
So that means this set of notes that we're doing today counts us out 1%. 7%. Proportionality theorems. We're going to use these theorems. Proportionality solve for missing parts using this theorem. Write that one down. Draw the picture on this one. This is the one we were talking about. When I said instead of splitting off the triangles. How many triangles in this picture? 2. 2 triangles. Even with the 2 triangles, we could separate that off and solve stuff using those 2 triangles. This one says that you don't have to do that if those 2 are parallel to each other. So if these 2 are parallel, then we can match up this part to this part and this part to that part, instead of splitting off the triangles like I tried to do on that one, but I messed up the math somehow. Now, if Hannah's confused by this theorem, could she still split off the triangles every time and do it that way? Yeah, that would still work. So if I had this picture right here, I knew this part was 8, I knew this was x plus 2, I knew this part was 12, and I knew this was 2x plus 1. If you split off the triangles, it makes it a little harder because to find this whole length, you got to add these 2 expressions. Find this whole length, you got to add these 2 expressions. So with the way I have it set up here using this theorem, we could just match it up. 8 matches up to 12. This matches up to that. The same as x plus 2 matches up to 2x plus 1. Now again, is that the only way that it could be set up? No, there's several different ways. And that's why I have 2 proportions over there that you could use. I didn't put down all the ones that are possible. I just put 2 of them. So you could match it up here to here, here to here. You could match it up here to here, here to there. Either one of those works. make that X right there. Tell me how to set up this first proportion then. Easiest way. 9 over 6.
Equals 4, no, X over.
X over
4.
4. Did we have to split off the triangles and go through all that? Somebody solve that. If I put an X right here, somebody else set up this one for me. If I can get it to go back. Somebody set up this one for me.
35 over X.
35 over X would work.
44 over 36.
44 over 36.
That's 6.
X is 6 over here. Does it make sense for that segment right there to be 6?
Yeah.
Look at it. We compared 9 to 6. What happens there? And don't go subtract. Bigger or smaller?
It's the same, it should be the same as 6.
It got smaller. What here was big, here was small, right? Is that the way it went there?
Yeah.
Yeah, so does that make sense? Yeah, probably. Anybody get this one? Do it real quick on your calculator. 28.6. Does it make sense for that segment to be 28.6?
Yes.
44 compares to 36. We went big to small. Big to small. Is that the way that one is? So it makes it easier sometimes. Now again, Hannah wanted, could she still split off the small triangle here, split off the big triangle and solve it that way? Yeah, what's the length of the side here in this small triangle?
4.
4. How about this side? It's X, right? Now here's where you gotta be careful. What's the length of that side?
15.
9 plus X, or X plus 9. What's the length of this side in the big triangle? 10. And you'd have to do that, separate it and set it up that way. Does it matter which way you do it? No, you're still gonna get the same answer. All right, write this one down, the converse of that. So this time, instead of knowing all the parts, or I'm sorry, instead of not knowing all the parts, we're going to know all those parts. And what are we going to be able to say about these two segments right here if those parts are proportional? What are you going to know about those two lines or those two segments? That they're what to each other? What was on the last one? What was on these? They're parallel to each other. So we're going backwards. We're saying if we know these parts are proportional, then these two right here have to be parallel to each other. Everybody got these sheets for the binder last time, right? So this one, we're just proving that those two lines are or those two segments are parallel. Probably ought to. If I do this, tell me a proportion I could set up over here in this example. Give me a ratio.
2/3.
Give me a ratio from here. 90 over 72. How about over here? 50 over 40. Now, what did I tell you a little while ago? Is that the way we really want to set them up? Why not?
Because there's no X, no variable.
Well, it's all right because this time we're trying to prove these two are. But what's wrong with those?
You even set it up to
They're, you gotta
Switch them. Put the lower ones on top so that we can use our calculators. All right? So instead of 90 over 72, what's this going to be? 72 over 90. What's the other one going to be? 40 over 50. Grab your calculator. Punch in 72, ABC button 90. Keep that in your mind. What it gives you? 4/5. Everybody agree with that? Now do this. 40, ABC button 50. 4/5. If those two are the same, what's that tell us about these two segments right here? Not congruent. They're parallel to each other. They're parallel to each other. If those two ratios come out to be the same, then they're parallel to each other. So it's the converse of the original one. Instead of starting off knowing that they're parallel and being able to find one of the missing parts here, now we know all the parts and we're going to go the other way. Next one, write this down. What's those arrows, those red arrows tell us?
Parallel.
Those 3 lines are parallel. What 3 lines are parallel?
R, S, and T.
R, S, and T. The other 2 lines, what are they called?
Transversals.
Transversals, good. Transversals. This theorem says if 2 transversals intersect 3 parallel lines, it could actually be 3 or more. Doesn't have to just be 3. Could be 4, 5, 6, 12, whatever. Then the transversals are divided proportionally. So as Lexi's drawing this and writing this, Lexi, when you go to set this up, there's several different ways you could do it. The way I would set it up, I'd match up those 2 parts as one of my ratios, those 2 segments as the other ratio. So this over that, this over that. Now you could also go this way. Here, 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 here. Either one of those is going to work. And that's what I wrote over here. That's what these 2 different ratios are. What has to be true before we can set up that proportion then? What did they tell us? What given information did we have this time? The lines are parallel, 3 parallel lines. You got to know that first. You know those are parallel, then you can set up the proportion using this theorem. So looking at this example, I know angle 1's congruent to angle 2. If angle 1's congruent to angle 2, what's that tell me about Main Street and 2nd Street? They're parallel. I know angle 2 and angle 3 are congruent. They're corresponding angles, just like before, right? Corresponding angles. What's that tell me about 2nd Street and South Main Street? They're parallel. What's that tell me about all 3 of these? They're all parallel. Now we could set up a proportion, matching up stuff. Pick me a number.
What?
A number that you see on the board here.
Oh, 120.
120. What's 120 match up to? Let's make this X right here. What is it? Where do you see 50 at? What's your other ratio going to be? So we did 120 to 150, X to 300. Is that going to work? Yeah. Let's try it and see. So we could do what? 120 over X. Everybody agree with that? So now we're going here to here. And then what's the other one going to be then? 150 over 300. Now sometimes you set them up a little different and it might make it a little easier. Because Hunter looks at this 150 over 300. Does he notice anything? It's half of it, isn't it? 150 is half of 300. So when we come over here, what should be true about 120 and X? Should be half, right? Now you got to be careful. 120 should be half of whatever X is. Does that mean X is 60? No, what is X? 240. So how long is this block right here? 240 yards. Does it make sense for that block to be 240 yards? Yeah, it makes sense. This one's 300, that's 240, that's 120. Looks like it's sensible. Look at this next one, if this is X. Angle 1, angle 2, and angle 3 are congruent. What's that tell us about these 3 lines? They're all parallel to each other, so we can use that theorem. Tell me the proportion we can set up. 16 over X. That's going here, matches up to there, and 40 over 30. To make this a little easier on ourselves, what could we do with those? What can I do with those zeros? Just take them off, get rid of them, divide both of them by 10. All right? Now, when we cross multiply, is that going to make it a little easier? Yeah, what's 4 times x? 4x, that's pretty easy. Going the other way, what's 3 times 16? Grab your calculator if you don't remember. You told me earlier, Bree, that you knew all the 16 facts. Divide by 4, what's x equal?
16.
Grab your calculator, Evan, quit being silly. 12. Does it make sense for that to be 12? Yeah, now Evan hollered out 16. Would it make sense for that to be 16? These two are the same. This one's 40 and 30. Does that make sense? No. So 12's got to be the one that we want. Make sure that your answer makes sense. Write this down. All of them. This one's a little confusing because it says triangle angle bisector. What that means is you have a triangle, and in that triangle, you're doing what? Try it again. You're bisecting an angle. So you got a triangle, and in that triangle, you're taking one of its angles and you're bisecting it. What's it mean to bisect an angle? So that's what we have right here. So we got this ray bisecting this angle in this triangle, and then we can set up proportions. This is the one that I like the most because I think it's the easiest to pick out how to set up the proportion. When I'm looking at this, I see this ray, it comes down here, it splits this side of the triangle into 2 parts, not to 2 congruent parts. Those 2 parts don't have to be the same. The angles have to be the same, but the 2 parts don't have to be the same. That depends on how the triangle is drawn, right? Lots of people think that y and z here have to always be the same, and that's not the case. So it splits it into 2 parts. And when I look at it, I just look at it like this and say, well, I know y is going to match up to the side that it's hooked to, which is x. So y over x, and then z over what? N. And just match them up that way. Now again, is that the only way to match them up? No, Lexi's going to look at it and she likes to match everything up a little different than what I do. She might do something like this and look at it, it's set up this way. She draws a fraction bar here, so what's her first ratio? X over n, and she knows that that equals, what's her second ratio? Y over z. If it's easier that way, do it that way. Down here at the bottom, I wrote it out in words, side part 1. What I mean is the side, it's split into 2 parts. This is part 1, that's part 2. Side part 1 over the side that it's adjacent to. Adjacent, what's adjacent mean again? Where they're hooked to, right? Whose desk is adjacent to this desk? Evans. Is Hunter's adjacent to this one as far as our rows go? No. Adjacent, right next to. Whose room is adjacent to mine? Mr. Alexander's. Mr. Slam's adjacent to mine? No, it's across the way. So adjacent, hooked to. So y over x, z is hooked to this side, which is n. These are a little harder. And these are the ones I'm going to put. These are the ones I'm going to put on the test next week. Not the little easy stuff all the time. It's got to be something that's got a little more difficulty to it. If I'm going to use that angle bisector, I have an angle right here that's being bisected. This side's being split into 2 parts, not 2 equal parts, but 2 parts. I know this part is x, Do I know this part? Not right now, I don't, do I? Can I find it? Be careful. 15, the whole thing is 15, so what do? 15 minus x. So this part right here is 15 minus x. These might be the kind of examples you want to jot down there in your notes so you got them. Now do I have all the parts that I need?
Yes.
Yeah, what proportion can I set up? Match me up two things. 7 to 13. Okay, I'll take that. So you match this up to this. Then what? 15 minus x over x. So you matched up here to here, then here to here. Is that going to work? Yeah. What do I have to make sure I do with this? Parentheses around that. My pen will ever work. Cross multiply, what's that give me? 7x. Cross multiply here. Let's go ahead and do the distributing. Somebody help me out. When we distribute, what's 13 times 15? 195? What's 13 times the negative x? Negative 13x. Now what?
Average 13.
Add 13x, get all the x's on one side, add 13x on both sides. 20x equals what? 195. Now what? Divide by 20. Is 20 going to go into 195 evenly? So don't look at your calculator silly when you get a decimal answer. What's it come out to be? Say it again. 9.75. Is it all right for that segment right there to be 9.75? Yeah, it's sensible. Would it have been all right for that segment to be 195? No, that wouldn't make sense because all the rest of the numbers are like 7, 13, and 15.
And the entire segment alone is 15.
Right, and the whole segment's 15. So if that's 195, that's sort of silly. Let's look at this one. What proportion can I set up here? This one's going to confuse everybody. Why does this one confuse everybody? It's got that radical in it, and it shouldn't. All right? You're going to look at this, and I promise you I'll put 2 or 3 of these problems on the test, just so Evan will look at me and go, oh, I don't know how to do those radicals. And then he'll give up on it. And this is probably the easiest problem on the test. All right? What's 1? We could go this way. 4 over 4 radical 2. I'll do that. So 4, that over that, and then 4 over what? Y. Now, we'll come back to that here in a second and solve that. I don't like setting it up that way. I want to set it up a different way. What's another way we could have set it up? You guys set this one up the way I want to set up this one. 4 radical 2 over y, and 4 over 4. Does anybody notice anything about that second ratio right there? It's 1, isn't it? 4 over 4. It's the same thing on top, same thing on bottom. What's that tell you about your other ratio then? It's got to be the same thing on top as it is on bottom. What do we got on top? 4 radical 2. Guess what's got to be on bottom then?
4.
So what's y equal? 4 radical 2. Did that make it real hard? No, just because that radical was there, it didn't make it very difficult. Now, if I go back over here, we did this last time. 4 times y is what? 4y. When we cross multiply this way, what do you multiply that 4 by? Do you multiply it by the 2? No, because it's 2 different kinds of numbers. You just multiply it by the outside number, which is 4. What's 4 times 4? 16. What else do you still have? The radical 2. It just stays the same right there. Don't make these harder than they are. All right? Forget the radical 2's there. What do you do to solve for y? Divide by 4. Guess what you do if the radical is there? Still divide by 4. These cancel out. Y, when you divide by 4, you're going to divide that radical 2 by 4? You're just going to divide what? The 16. What's 16 divided by 4? What happens with the radical 2? Just bring it down. It stays the same. Is that the same answer we got either way? Don't make, just because something has a radical in it or a decimal or a fraction, don't make it harder than it has to be. All right, write down this first one. everybody can take Austin when I take off points on your binder for stone.
Wow.
I'm not even turned one in, to be honest.
Holy
I think
soul.
this really is so saturated.
You sold it?
You can meet some of this around here. Not even
Just write down the first one, that's all we want.
It's not.
We're gonna do a whole bunch of these problems for the rest of the year, and you gotta be able to do them. What's the first thing I'm gonna do in this proportion?
Parentheses.
Before that, put parentheses around this. Put parentheses around those two. Now we're gonna cross multiply, and I'm just gonna write it out. Multiplying this way. So what am I gonna write? 2x, don't do the multiplying yet. 2x times what? X minus 3 equals, what's on the other side?
3x and x plus 5.
X plus 3. Now, 3 is going to help us with this. When we distribute here, what's 2x times x give you?
2x squared.
2x squared. What's 2x times 3 give you? Negative 6x. And I highly suggest you write this down so you got the example there in your notes. We do the other side. What's 3x times x give you?
3x squared.
3x squared.
Plus 9x.
That's an x. My pen's not cooperating. Plus 9x. You got an x squared and x in the same problem. Is this going to be an easy problem where we can just solve it normal? No. First thing we're going to do is get all the x squareds on one side. So I'm going to subtract 2x squared on both sides. What happens with these? Cancel out. What's here? Negative 6x.
X squared.
That's just x squared
Plus 9x.
plus 9. Now, a lot of times we'll want to take everything to one side and get 0 on another side when we have an x squared. This time you don't have to, and I'm going to show you why. We move this 9x over to the other side. So we subtract 9x on both sides. These cancel out. What's left on the right-hand side?
X squared.
X squared. What's a negative 6x and a negative 9x give you?
Negative 15.
Negative 15x. We get it down to this far. What we can do here to solve this, what's on both sides?
X.
An x. So if we divide this side by x, what's left on this side?
X.
Negative 15. You divide the other side by x.
X.
Just x. What's x equal?
X 15.
Negative 15. Write down this next one. What's the first thing you're going to do on it?
Parentheses.
Put parentheses around it. So as you're writing it down, you put the parentheses around these. You got to be able to deal with the radicals, the squares, and all that stuff. Tell me what to write when I cross multiply. Good. Equals what the other way? Then what are we going to do? Distribute. What's this give me when I distribute here?
4x minus 3 squared. 10x plus 5.
Everybody agree with Evan on both those? Now what? What do you think you do next? This time's a little different
Minus
because
4x.
this time we have a regular number. Alright? So what we want to do this time is we want to move everything to one side. When you move everything to one side, you want your x squared term to be positive. Right now, is the x squared term positive or negative?
Negative.
So we want to move it to the other side. When we jump it over to the other side, what's it become?
Positive.
A positive. Alright? When we jump this 4x over to the other side, what's it going to become? If good. It's positive right now, what's it gonna, it's gonna become a negative, alright? And if you can start doing this without really thinking about it a whole lot and just moving things instead of writing it out step by step, it's gonna make everything a lot shorter. So when I move everything over there, we wanna put it in order also. So the x squared is gonna come first. Well, that x squared, is it gonna be positive or negative when I move it over there? Positive, so I just move it over there. The 4x, it's gonna become a negative 4x, and we're gonna combine it with this one. What's 10x and negative 4x give us?
6x.
Positive 6x. And we still got what over there that we haven't done anything to?
5.
Plus 5. What's left on the left-hand side?
Zero.
That's what we want. Alright? No, that's what we want so that we can do what we have to do to solve it. And that's what I'm going to show you next. To solve this, you got to factor. Bree's going to help us with this, right? Isn't that what you're doing right now in the other class? You passed it? Somebody was doing it.
Yeah, we already passed that.
So we want to factor. First thing you're going to do when you're factoring, draw 2 parentheses. Usually when I taught algebra, I told them that I could teach monkeys to draw 2 parentheses. Apparently I can't teach Lexi because she's not writing any of this down.
I have all of it.
Alright, I'm sorry, I apologize. So draw the 2 parentheses. Now what you want to do is look at the first term, the x squared. What's the factors of x squared? What
X.
times what will give you x
X
squared?
and X.
Anybody remember that from algebra last year?
Yes.
When you break this down, you put an x here, you put an x there. Then you look at this last term. It's a positive 5. And what you want to do is find the numbers that multiply together give you positive 5. Give me
2.5.
5 and 1. Do we want to do what Evan just said, do 2.5?
No.
Absolutely not. We don't want decimals. 5 and 1. Any others?
No.
There actually is one other
1
pair.
and 5.
2 and 3.
About negative 5 and
Negative 1.
negative 1. Do those multiply together to give you positive 5?
Yep.
Now, what we want is the pair that multiply together give us 5 and add together to give us 6. Either one of those two add together to give us a positive
5 plus
6.
1.
5 and 1. So what goes right here?
X plus 5.
X plus 5. What goes right here?
X plus 1.
X plus 1.
Yes.
That's our factored form. No, that's not our answer because we're still trying to solve for X just like we would have been trying to solve for X every single other time. What do you do with that? Now help us out, Bree, if you already passed this. We want this to equal 0. What number is going to fit in here for X to make that first parenthesis 0? What plus 5 makes that 0? Negative 5. So that's one of our answers. X equals negative 5. What goes in here, what would fit in there to make this second parenthesis 0? Negative 1. So what's the other answer X could be? You remember that? Good. Alright, that's your assignment, page 450. Make sure you write it right on the start one. Again, we're going to put parentheses around each of the binomials. Anything that's got 2 terms in it, put parentheses around it, makes it a little easier. We cross multiply. So for this first part, we got 2 times x plus 1. On the other side, when you do this, and I'm going to write this out, hopefully you remember some of this from algebra, you got 1 minus x, and you got x minus 8. I know this one here is sort of backwards, but it's just the way it is. Hopefully from algebra you remember FOIL. You do first, that's what the F stands for, outer, inner, and last. We'll do that here in a second. We're going to do distributive property over here. So you got 2x plus 2 equals, here we do the first terms, that's the 1 and the x, so we got 1x. We do the outer terms, that's the 1 and the negative 8, so that's 1 times negative 8 is negative 8. We do the inner terms, which is x, negative x times x, which is negative x squared. And then we do the last terms, which is negative x times negative 8, which is positive 8x. right-hand side, we're gonna collect like terms, so over here on the left, I just got 2x plus 2, I'm gonna leave it that way. Right-hand side, I collect like terms, and I got the 8x and the 1x, that makes 9x. Still got minus 8 minus x squared. This next step, I'm gonna do this pretty quickly. We wanna move everything to one side. What you should look at is the squared term. Since it's a negative on the right-hand side, if we move it to the left, it's gonna be a positive. So we're gonna move everything to the right-hand side. So we're gonna move this 9x to the left-hand side, sorry. We're gonna move the 9x to the left. We're gonna move the negative 8 to the left. We're gonna move the x squared to the left. And when we move them all, jump them all over the equal sign, they change signs. So we got 2x plus 2, and we move the 9x over so it becomes a minus 9x. We move the 8 over and it becomes a positive 8. We move the negative x squared over and it becomes a positive x squared. And what's left over here, once we've moved all three of these, what's left on that right-hand side is 0. Then we collect like terms. When we collect like terms, we always want to put it in descending order according to their degree. If you remember from algebra, the x squared, that has the highest degree. It's got a degree of 2, so it goes out front. X squared, so we've taken care of that term. Then we got the 2x and a minus 9x. A 2x and a negative 9x gives us negative 7x. So that takes care of those two. Then we got the 2 and the 8. That gives us 10. And that still equals 0. I'm going to rewrite this because I'm running out of space down towards the bottom. This is x squared minus 7x plus 10 equals 0. Now what we got to do with this trinomial is we got to factor it. We look at the first term, which is the x squared, and you should know that x squared breaks into x right there in that first spot, x right there. Then we look at the last term, which is plus 10. We want two numbers that multiply together give us a positive 10, and added together give us that middle term, which is negative 7. So if I'm looking for the factors of 10, I could do like 1 and 10. But added together, 1 and 10 give us 11. That's not what we have in the middle. I want the ones that multiply together. Or I'm sorry, that added together give us that middle term. So if I look at 2 and 5, those multiplied together give us 10, but added together they give us a positive 7. And we have a negative 7. So what we want is a negative 2 and a negative 5. So those are the factors that we're going to use, negative 2 and negative 5. And all you do is write them right in here. Negative 2, negative 5. This is our factored form. This right here is our factored form. To solve that, all you're going to do to solve it is you split apart the parentheses. Either that parentheses equals 0, or this parentheses equals 0. So we split it apart and we say either x minus 2 equals 0, or x minus 5 equals 0. Some of these you can just solve in your head. Just look at this one and say, what fits in there for x to make this first one here 0? Well, x has to be 2. So that's one of our answers. The second one, we look here, and we say, what fits in here for x to make this one 0? And in this case, x would have to be 5. Those are our two answers. When you're doing the algebra, like this problem, you're going to end up with two answers. X equals 2, x equals 5. For some of the geometry stuff, both answers won't work. So you might need to plug in x is 2, plug in x is 2 on some of the problems, or some of the segments or angles, and see if it works. Since this was just algebra, we don't have to worry about it. Plug in 2, plug in 5, and see if it makes sense for the angles to be whatever you come out with. Because you got to remember, angles can't be negative and segments can't be negative. So that's this third one. This third one right here, x equals 2 or 5. on this one, I'm gonna start, I'm gonna put parentheses around this, and I'm gonna actually start writing it up here. We got, that way we got x times x minus 4 when we distribute, or I'm sorry, when we cross multiply. And this way we got 2 times 2x minus 6. We distribute out here, end up with x squared minus 4x equals here 2 times 2x is 4x, 2 times negative 6 is negative 12. And again, in case I confused you, we're going to move everything to one side. Well, we got the x squared over here already and it's positive, so we're just going to leave it over there. So we're going to move this 4x over, and I'm going to actually work it out this time. We're going to move the 4x over. That means we got to subtract 4x. Only put it with other like terms. So we're going to put it with the other minus 4x over there. So we got x squared minus 8x still equals, these cancel out, a negative 12 on that side. Then I'm going to add 12 to both sides. When we move the 12 over here, 12 is not a like term with the x squared. It's not a like term with the negative 8x. So it's just going to be x squared minus 8x plus 12. We just sort of added on at the end there. Over on this side, these cancel out, and there's nothing left over there, so we got to replace it with the 0. Now we have this x squared minus 8x plus 12 equals 0. And we're going to draw our two parentheses. And we're going to factor. Factors of x squared are x and x. So x goes here, x goes there. Then we look at the third term again. And that third term this time is a positive 12. We want two numbers that multiply together, give you a positive 12, and added together give you the middle term, which is a negative 8. So maybe I try like 3 and 4. 3 times 4 gives me a positive 12, but add together they give me a positive 7, so that won't work. So maybe I try negative 3 and negative 4. Negative 3 times negative 4 is positive 12, but add together you get negative 7, that won't work. The ones that do work, negative 2 and negative 6. Negative 2 times negative 6 gives you a positive 12. Negative 2 plus negative 6 gives you a negative 8. So those are the ones that go in here. So you put minus 2 here, minus 6 here. And again, you could just solve it from this position right here. Instead of breaking it apart, you just look at this parentheses. You say, okay, what fits in here in place of x to make this 0? Well, for that to be true, x would have to be 2. Or we look at this one and say, what fits in there to make that set of parentheses 0? In that case, we get x equals 6. Those would be our two answers for this fourth one right here. X equals 2 or x equals 6. And again, not always will both these answers work when we're doing geometrical stuff or real life stuff. But for the algebra, you got to give both answers.